Welcome back to the Deep Dives, where we take your curiosity, stack it up against our research, and try to deliver the highest yield insights right into your ears.
And if you're here, you want to get informed, but you want to do it quickly and thoroughly.
Exactly, especially when we're talking about the frontiers of tech. And today, we are focusing on a true titan of computing, Linus Torvalds.
I mean, this is the mind that created Linux.
The kernel that powers, well, pretty much everything important. Servers, Android phones.
And Git. You can't forget Git. Modern software development just wouldn't be possible without it.
Right. And if you know anything about Torvalds, you know he's a pragmatist. He's famous for being exceptionally frank, very skeptical of any tech wrapped in marketing hype.
Which is what makes this so interesting.
It is. Because now, surprisingly, he's engaging with generative AI, specifically through an approach he calls vibe coding.
Vibe coding? It sounds almost casual.
It does. Okay, let's unpack this. Our mission for this deep dive is to get past the headlines. We're going to explore how an icon known for skepticism is actually using AI.
And we're going to weigh its strengths and its limitations with some hard, verified academic evidence.
So you can make a smart, informed decision about whether to integrate this into your own demanding routine.
It's a really fascinating turn because Torvalds has always been that vocal skeptic, the one cutting through the noise.
Yeah.
And his recent experimentation, it doesn't signal some kind of conversion to the hype. It's more of a pragmatic adoption of a very specific utility.
Okay, so let's start right there. What exactly is vibe coding? Because, like you said, it sounds maybe a little irresponsible, and Torvalds doesn't do irresponsible.
Right. So vibe coding is really a recognition of a shift in the human-machine partnership. It's a programming style where you, the user, don't write out every single line of code.
You're not writing the detailed specs.
Exactly. Instead, you provide a vague description, a conceptual goal, a vibe.
A vibe.
The AI takes that vibe and generates a draft. And this draft is almost always syntactically correct, structurally plausible.
So what's the human's role then?
The human becomes the editor, the curator. The chief architect, really.
Right.
You take that draft, you adjust it, you polish it, and you make sure it actually fits into the larger system.
So it moves the effort from, like, meticulous line-by-line typing to high-speed drafting and then expert revision.
That's the perfect way to put it.
I think we had an analogy for this. It's like a master chef giving a simple instruction to a sous chef. Something like, I need a complex sauce, but make it taste earthy and tart.
And the sous chef provides that draft. But it's the master chef who adds the critical seasonings, the secret ingredients, the timing. That's what makes it exceptional.
And Torvalds has actually used this.
He has, openly, in what he calls non-critical utility projects that he shared on GitHub. He specifically mentioned using Google's anti-gravity AI assistant for certain parts.
And what did he think?
He called the process fun and very useful, but, specifically for these kinds of low-stakes experiments.
Okay, but isn't this a little hypocritical? He's using this powerful generative tool, but at the same time, he's publicly dismissing the term AI as just pure marketing. How do we square that circle?
That is the core philosophical battleground. And what's so fascinating is that he absolutely despises the term artificial intelligence.
Hates it.
He sees it as intentionally misleading, overpromising. For him, this technology isn't intelligence in any meaningful way. It's just a sophisticated pattern detection engine.
He's stripping away the mystique.
Exactly. He prefers to see it purely as a utility. I think he famously called it an autocorrect on steroids.
An autocorrect on steroids. I like that.
Its real power, in his view, is spotting structure and patterns and even errors in existing code.
So he trusts it for maintenance, but not for creation. Is that the idea?
That is the critical distinction for him. It all comes down to creativity and risk. He is a huge believer in using AI for code maintenance, for checking patches. Oh, yeah. He's reported that AI has actually found genuine bugs in the Linux kernel development flow, bugs that he and other core developers had missed.
Wow.
When it's checking existing patterns, it excels. But when it comes to writing new, innovative code, the complex system-level design work,
That's where he gets off the train.
he says he's much less interested. He sees real programming, the innovative part, as a fundamentally creative and human process. The AI just doesn't have that holistic architectural understanding.
Okay, that makes sense. It's a powerful assistant for the mundane, but not a visionary.
Precisely. The AI is basically predicting the most statistically probable output. It can mimic structure, sure, but it can't conceptualize the deep intent behind a decision.
Or anticipate a future conflict with a system that hasn't even been written yet.
You've got it. Maintenance is about adhering to existing patterns. That's the AI sweet spot.
So this is where his philosophical caution turns into a really stern, actionable warning for anyone listening.
This is the essential caveat. This is the part everyone using these tools must internalize. Torvalds says the prerequisite for vibe coding to be safe and effective is that you, the user, must have a deep, expert-level understanding of the code the AI generates.
And what if you don't? What happens if that understanding is missing?
You're just importing unknown complexity and technical debt into your project. You create a black box problem. The code might work now, but the minute a dependency breaks or an edge case pops up,
The programmer who didn't really understand the draft is completely lost.
completely. And he uses that wonderfully memorable analogy to really make the point stick.
Right.
He warned that if you don't understand the underlying code, the whole thing is like letting a monkey write Shakespeare.
Ah, okay.
The result might look perfect on the surface, syntactically flawless maybe, but underneath it's chaotic and totally unmaintainable when you face a real complex kernel-level challenge.
The implication for, say, a junior programmer is enormous. The tool amplifies skill, but it also amplifies ignorance.
Precisely, which raises a really important question. Why do experts, like Torvalds himself, seem to gain less from the generative side of this technology, at least in these high-stakes projects?
It's not about typing speed.
It's not about typing speed, it's about cognitive overhead. When you're an expert, your skill is in architectural innovation, in understanding context that spans thousands of files. The AI generates code, yes, but the human role remains essential for that critical planning and debugging of those really nuanced, high-impact bugs.
The AI is an amplifier, but you have to know which direction to point it.
And you have to be able to fix it when it gets it wrong.
So Torvalds gives us the philosophy, but does the data actually support this split between maintenance, utility, and creative risk? We need facts, not just vibes about vibes.
Absolutely. And we've synthesized evidence from some major academic and industry research, and the results are surprisingly mixed. This makes integrating AI a complex strategic choice, not just a simple productivity button.
Okay, let's start with the clear wins. Where does the data show AI is, without a doubt, a productivity booster?
We see massive positive gains, especially for routine work and, crucially, for novice programmers.
Okay.
For instance, a 2024 paper from MIT Sloan. They analyzed the rollout of GitHub Copilot across 3 different tech companies. The overall finding was a 26% average increase in completed tasks.
26%.
Yeah.
That's a transformative number for any business.
Yeah.
But you said the benefit was concentrated in one group.
That's where the real insight is. The biggest productivity gains, up to 39%, were seen among junior developers.
Wow, almost 40%.
And if you think about it, it makes perfect sense. Junior developers spend so much time on basic syntax errors, looking up common functions, writing boilerplate code.
The AI just handles all of that.
Instantly. It removes those low-level, high-friction tasks. It's like a highly knowledgeable sidekick that frees them up to focus on the bigger picture.
So it's not making them a better architect overnight, but it's clearing the path so they can learn to be one.
Exactly. And other reports reinforce this. Anthropic in 2025 reported their internal use of Claude led to a 50% productivity boost. 50. Now, you have to read internal studies with a bit of caution, of course, but the trend is undeniable. AI excels at generating functional drafts and speeding up iteration on known problems.
Okay, this sounds like an open and shut case. AI makes us faster. But this is the deep dive. So I know there's another side to this coin.
There is.
Let's flip it over and look at the surprising slowdown, because this is where the story gets really complicated, especially for experienced developers.
This is the counterintuitive finding that should genuinely worry industry leaders. We turn to a 2025 randomized controlled trial, an RCT from Meteor. They're a research collective known for really rigorous AI studies.
And what did this highly controlled study find with experienced programmers?
It found the opposite of acceleration. The study had 16 experienced open-source developers using advanced tools, Cursor Pro, Claude 3.5 on complex real-world tasks, and the finding was startling. Using AI actually increased their time to completion.
Wait, increased?
By 19%. It slowed them down.
So using these cutting-edge tools made expert programmers nearly a fifth slower. That directly validates Torvalds' caution.
It does, but the next detail is even more crucial.
There's more.
Despite being objectively 19% slower, those same developers believe they had been accelerated by 24%.
Whoa, that is a staggering disconnect. They felt faster, but the clock said they were slower. Why? What causes that kind of cognitive bias?
There are a few likely reasons. First, the AI does give you rapid, plausible output. You get that immediate dopamine hit, that illusion of progress, the vibe. Second, the real slowdown comes from the cognitive overhead. The time you spend engineering the perfect prompt and then critically reviewing, testing, and debugging the AI's subtle failures. An expert might spend more time fixing a complex AI error than they would have just writing the correct code from scratch.
So the initial generation is fast, but the verification and repair costs are higher. That makes total sense in a complex system. The AI misses the one tiny context-specific detail, and the expert has to spend forever finding it.
Precisely. If the task is, integrating a novel data structure deep inside a legacy system, the AI just won't have the architectural context. The vibe is good, but the detailed application is flawed, and that's why an METR study is so important. It moves beyond boilerplate and into real-world complexity.
So what does this all mean for the learner listening right now? We've got an icon like Torvalds using the tool but issuing these severe warnings, and then we have data that says AI is a powerful utility, but it is definitely not a magic solution.
It means we have to understand the dichotomy. The data is clear. AI excels at routine tasks, boilerplate, and maintenance. It validates Torvalds using it as an autocorrect on steroids.
Which is why it's great for junior devs and for bug checking.
But the data also strongly suggests it can actively hinder expert performance when the task demands deep structural innovation. Architectural complexity.
In other words, the core of programming, the understanding, the innovating, the debugging of edge cases, that remains firmly human.
It echoes Torvalds' philosophy perfectly. Use AI as a strategic ally, not as a crutch for understanding.
And this leads us to our final provocative thought for you to consider.
Right. Given those METR findings, that developers felt 24% faster while objectively being 19% slower, how will the industry measure true productivity and value moving forward?
That's a huge question.
If subjective satisfaction clashes so strongly with measured data, are our traditional metrics even useful anymore when we integrate AI? It's a fundamental challenge for management and engineering teams everywhere.
It really is. We need new ways to measure value beyond just lines of code or tasks completed.
Exactly.
Okay, for the learner and all of us, let's wrap up with a couple of actionable challenges based on this split we've been discussing.
Let's do it.
Challenge number 1. Try vibe coding yourself on a small, low-stakes project. Use a free tool, Copilot or Claude, and give it a vague idea, something like a small script that checks server logs for memory errors and emails me a summary.
A classic utility script.
Right. Adjust what it gives you, polish it. But use a timer.
No.
Did it actually save you time on a boilerplate task, confirming that MIT Sloan data? And most importantly, did you fully understand the code it produced?
That's the key.
Challenge number 2. Reflect on that MEPR data. The perceived speed versus the objective slowdown. If you were a CTO or a dev lead, how would this mixed evidence change your policy for adopting AI on your team?
Would you limit its use to maintenance and documentation, like Torvalds suggests? Or would you risk it on more creative, complex projects?
Thinking critically about the tools and the cognitive cost of using them is just as important as the code they generate.
We really encourage you to seek out the source materials yourself. Dig into those numbers.
Yes, exactly. Keep your vibes high, but keep your understanding higher and your code clean. We hope this deep dive gave you the insights you needed to move from just being informed to being truly well prepared.
Until next time.